Breaking the 1,000 miles per hour barrier on land is not just about power. It's about challenging the very laws of physics. For gearheads, this is the ultimate adventure, a dance between cutting-edge engineering and human courage. Get ready to explore the secrets of extreme speed, from the invisible forces that hold us back to the innovations that promise to revolutionize the impossible. This is the moment to discover what it truly takes to achieve the unattainable. Record-breaking speeds. Imagine the scene. A car, the SSC Tuatara, flying down the road at an astonishing 316 miles per hour, breaking production car records. For gearheads, this is the fulfillment of a dream of speed and precision engineering. However, if we go back 23 years, we see an even more impressive feat. The Thrust SSC car, which reached an incredible 763 miles per hour. The question that lingers is, why, with so much technological advancement, have we still not surpassed this astronomical mark? The answer is not as simple as it seems. While the SSC Tuatara has shown that we are on the right path, reaching 763 miles per hour in a car is not just a matter of more power. There are invisible forces working against every attempt to break this record. For the true gearhead, understanding these forces is like solving a complex puzzle where each piece reveals something new about the limits of physics and automotive engineering. And this is where the story gets even more intriguing. When it comes to land speed records, the challenge is much more than just building a fast car. There are barriers beyond mechanics and technology, challenges that test not only the car but also the courage and skill of the drivers. These questions make us wonder, what is truly preventing us from reaching the 1,000 miles per hour mark? It's a game of power and endurance, and understanding this is the first step for anyone who wants to become a true master in the automotive world. Challenges in reaching 1,000 miles per hour. Reaching the 1,000 miles per hour mark is not simply a matter of flooring the accelerator. For any self-respecting gearhead, it is essential to understand the monstrous forces that manifest when trying to break this barrier. The mechanics behind a car at this speed involve a constant battle against resistances. Mechanical resistance, rolling resistance, and the most challenging of all, air resistance. Each of these forces acts like an invisible hand, pushing the car back with increasing strength as speed increases. It's important to remember that air resistance does not grow linearly but exponentially. This means that as the car accelerates, the amount of energy required to continue accelerating increases dramatically. To put this in perspective, think about running against the wind. The faster you run, the stronger the wind seems against your body. Now imagine this multiplied hundreds of times. This is the challenge for those who dream of breaking the 1,000 miles per hour mark. And for a gearhead, understanding this reality is a crucial step in the quest for this mythical speed. So, how do we overcome these challenges? The answer lies in innovation and audacity. It is necessary to think outside the box and consider solutions that go beyond conventional engines. But even with the best engineers and the most advanced technologies, the laws of physics are still relentless. Air resistance, in particular, is a barrier that still challenges the best minds in the automotive world. And this leads us to explore a bold solution: the transition to jet and rocket engines. But is this enough? The next phase of this journey explores exactly this question: air resistance and drag. When it comes to extreme speeds, air resistance is like that relentless villain in a thrilling race. For gearheads who seek to understand what limits race cars from reaching their maximum potential, it is essential to understand the impact of aerodynamic drag. As a car accelerates, the air around it acts like an invisible wall, making each increase in speed exponentially more difficult. The faster the car goes, the greater the force of air resistance it faces, creating a constant cycle of challenge for engineers. The idea of overcoming drag is not just a matter of power, it is a matter of smart aerodynamic design. Think of Formula One cars, for example. They are designed not only to be fast but also to cut through the air efficiently, minimizing drag as much as possible. Every curve, every angle is calculated to reduce resistance. And when we are talking about trying to break the 1,000 miles per hour barrier, this knowledge becomes vital. For aspiring gearheads, it is this mindset of understanding the minute details that distinguishes an amateur from a true enthusiast. But the challenge does not stop there. Even with the best aerodynamic design, there is a point where air resistance becomes nearly insurmountable with traditional engines. This is where we enter the need for a new approach, one that involves using jet and rocket engines. These engines do not rely on traditional torque to generate motion. Instead, they produce direct thrust that is more efficient at extreme speeds. And this leads us to the next chapter of our journey, where we explore the crucial transition to these revolutionary technologies. Transition to jet and rocket power. The transition to jet and rocket engines is not just an evolution. It is a revolution in the world of land speed records. For gearheads, This change represents a new horizon of possibilities where the traditional engine gives way to technologies that seem straight out of a science fiction movie. Instead of spinning wheels with torque, these engines generate direct thrust, pushing the vehicle forward without the limitations of mechanical traction. This approach is fundamental when seeking to break the barriers imposed by extreme speeds. Why is this change necessary? At speeds above 500 miles per hour, the laws of physics start to become a formidable adversary. Air resistance, as mentioned earlier, becomes exponentially greater, and the need for a power source that does not rely on spinning wheels becomes evident. Jet cars like the Thrust SSC, which broke the sound barrier, are the perfect example of how this technology can be applied. For a gearhead, this transition is not only fascinating but also a study of how innovation can defy the impossible. However, even with the impressive power of jet and rocket engines, there are still challenges to be faced. These vehicles need to be designed to handle extreme G-forces and maintain stability at speeds that defy comprehension. The pressure on the driver's body and the vehicle's structure is immense, and any failure can be catastrophic. This is where the Bloodhound LSR project comes in, with its audacious vision of breaking the 1,000 miles per hour barrier. But will they succeed? This is the mystery we will explore next. The Bloodhound LSR project. The Bloodhound LSR project is more than just an attempt to break a speed record. It is a true adventure at the frontier of engineering and human courage. For gearheads, the Bloodhound represents the culmination of years of research and innovation. With the ambitious goal of reaching 1,000 miles per hour, the vehicle has been meticulously designed to maximize thrust and minimize aerodynamic drag. The sleek shape of the Bloodhound, combined with its jet engine and rocket, showcases the level of sophistication required to tackle this monumental challenge. But the road to 1,000 miles per hour is not easy. In addition to aerodynamic challenges, the Bloodhound project faces obstacles such as the extreme G-forces acting on the driver and the structural integrity of the vehicle. Imagine the force being so intense that the driver's skin is literally pushed back. This requires intense physical preparation and the use of state-of-the-art materials to ensure the car and driver remain intact. For aspiring engineers and gearheads, understanding these details is essential to appreciate the complexity of the challenge that Bloodhound faces. However, the challenges are not limited to physics and engineering alone. The location also plays a crucial role. The Bloodhound chose Hakskeenpan in South Africa because it is a flat and extensive area, large enough to achieve such speeds without obstacles. But even with the ideal location and advanced technology, the issues of resistance and control at extreme speeds still leave many questions unanswered. What else can be done to ensure the project's success? This is what we will uncover as we explore the technical and human limits of speed record attempts. Technical limitations and human constraints. Surpassing the 1,000 miles per hour mark is not just a test for technology, it is a direct challenge to human capabilities. For gearheads, this is a journey of discovery that goes beyond machines. We are talking about understanding the physical and mental limits that a human can endure. At such extreme speeds, G-forces become an invisible enemy, pressing on the body and demanding uncommon resilience. The human body was not designed to withstand these forces, and every additional second at 1,000 miles per hour is a victory against the natural limits of physiology. Additionally, there is a technical complexity that few imagine. Keeping a vehicle stable at such high speeds requires mastery over engineering that borders on the impossible. The materials used must withstand immense pressures without failing, and control systems need to react in milliseconds to prevent any loss of stability. A small mistake can result in disastrous consequences. This makes the pursuit of speed records not just about power but about extreme precision and control. So why keep trying? For true speed and innovation enthusiasts like gearheads, the challenge is its own reward. It is an opportunity to push the boundaries of what is considered possible. However, beyond the technical and physical challenges, the environment plays a crucial role. And it is precisely this environment, the chosen location for these adventures, that could be the key to finally breaking the record. In the next step of this journey, we will see how terrain and environmental conditions affect these ambitious attempts. The environment, an unseen challenge. The environment is as much an adversary as any other when attempting to achieve extreme speeds. For gearheads who understand the importance of details, choosing the right terrain is crucial. The Bloodhound LSR chose Hakskeenpan in South Africa not by chance. This dry plain offers a smooth and flat surface, essential for maintaining stability at speeds above 700 miles per hour. Any imperfection on the track can be fatal, so every inch is carefully examined and prepared. It's like a dance between man, machine and nature, where all elements must be in perfect harmony. Besides the surface of the terrain, weather conditions also play a fundamental role. At such high speeds, even the slightest gust of wind can alter the car's trajectory and put everything at risk. The air temperature and humidity also influence air resistance, directly affecting the maximum speed that can be achieved. Therefore, understanding the environment is more than a mere consideration. It is a science in itself. For gearheads, this is a valuable lesson on how nature and technology must work together. These environmental issues are not just challenges to be overcome, but also opportunities for learning and innovation. Every test, every race provides valuable data that can be used to improve future projects. And it is this continuous quest for knowledge and advancement that keeps the spirit of enthusiasts and engineers always alive. But of course, this makes us wonder. What will it take to finally break the 1,000 miles per hour record? The answer may lie not only in the machines but in the very human essence of perseverance and innovation. Now that you know what it takes to reach 1,000 miles per hour, what would you do with this knowledge? Share your thoughts in the comments. And don't forget to subscribe to the channel for more amazing content. Oh, and if you love speed, check out our latest video on the differences between NASCAR and Indy. See you next time, Gearhead.